Hey guys, open your notebook to page 60. I believe 100's halfway, by the way. We're already on page 60. All right. Well, I've lost my black pen. 60. 7.2. Isosceles and equilateral triangles. And label 60 and 61 that. And these are foldables today as well, but like I've said in the past, if you don't have a printer, get a piece of paper, fold it in half, and make your own foldable. Okay? Alright, so we're talking about, well, obviously, isosceles and equilateral triangles. We'll be talking about the theorems that go along with those, and then we will solve some problems as well. Alright, so we got an isosceles, and we got an equilateral triangle. We're going to do the definitions on the front of this foldable. So I've got this foldable, and I'm going to cut it. Drop my glue stick. We're going to cut it like this. So I've got isosceles and equilateral. So isosceles, which you should already know, is a triangle with two congruent sides. So we're going to write that definition. So triangle with two congruent sides. Okay? And equilateral is a triangle with three congruent sides. Put all instead of three. Okay? Now that you got that, go ahead and open it up. We're going to talk about the theorems that go along with them. Okay, the isosceles triangle theorem says if two sides of a triangle are congruent, then their base angles are congruent. So if you have two sides congruent, then the base angles, the bottom ones, are congruent. Not necessarily the bottom, the angles down here that are not in between the congruent sides. So let's talk about this. In an equilateral triangle, you have a vertex angle, you have a base, you have base angles. Okay. The opposite, the converse, remember, is flipping it. The converse says if two base angles of a triangle are congruent, then the two legs are congruent. So if these are congruent, then sides are congruent, or the legs, which is just sides. Okay, let's talk about an equilateral triangle. In an equilateral triangle, if all three sides are congruent, then all three angles are congruent. If all three are congruent, then all three are congruent. By the way, since they're all congruent, it's 180 divided by 6. No, 180 divided by 3. 1, 2, 3. So they are 60 degrees apiece. The converse of the equilateral triangle theorem says if all three angles of a triangle are congruent, then all three sides are congruent. So if you have this, then you have this. Okay? We're going to glue that in on page 60 and then actually do some work. And I got to pick up my glue stick now it drops. 61, we're going to put in our other problems. I'm just going to go ahead and glue them while they're sitting here. Okay, and it says find the indicated measure. So here we have an isosceles triangle because it's got these two marked, which means that S is also X. So we're supposed to find the measure of angle T. Since we have X, X, and 3X, we're going to set up that 3X plus X equals 180 degrees, since there's 180 degrees in a triangle. Okay, 3, 4, 5 X's equals 180. Divide by 5. X equals 36. Not degrees. Okay, this says find the measure of angle T. T is 3 times 36. So the measure of angle T is equal to 108 degrees. Measure of angle P. Okay, this is what I meant by the base is not always the bottom. It's the ones that are not in between the congruent sides. So the base angles are here, which means P is also 3X plus 3. We are looking for P. We're going to set up just like we did. 3X plus 3 plus 3X plus 3 plus 5X minus 2 equals 180. 3 plus 3 is 6, and 7, 8, 9, 10, 11X. 6 minus 2 is 4. Subtract 4. 11X equals 176. 5 by 11. X equals 16. We are looking for the measure of angle P. 3 times 16 plus 3. That is 51 degrees. Alright, last one here. This shows that there are 3 congruent angles. That means all of these are congruent. We're trying to find BC. So we're going to set these equal to each other. We're going to solve for y and then plug it into either one. It doesn't matter which one because all 3 sides are congruent. So 3 over 10 y plus 9 equals 4 over 5y minus 1. Now, I've gone pretty fast through this. I would pause the video, try to solve this on your own, okay? I'm actually going to change this to 4/5 to a common denominator, so I'm just writing everything down. But 4/5 is 8/10. That's going to help us subtract. So I'm going to add 1 and subtract 3 over 10 in the same step. That is 10 equals 5 over 10y multiply by 10 over 5 y equals, that's 100 divided by 5, so y equals 20. And then plug back in, it doesn't matter which. I'm going to do 4/5 y minus 1. Four fifths times 20 is 16. Minus 1 is 15. So BC is 15. There you go. Today you're using these to solve problems. I'll see you tomorrow.